All right, let's take a look at geometric sequences. So, geometric sequences are similar to arithmetic sequences in that they're a set of numbers that follow some sort of pattern to get from one term to the next term, a sequence going from one term to the next. They, unlike arithmetic sequences, geometric sequences, the pattern they follow is exponential. To get from one term to the next, we multiply or divide, not add or subtract. So, in here, in geometric sequences, we have something called the common ratio. We don't have a common difference. Common ratio, right? How can we find the common ratio? Well, let's go back to labeling our sequence, right? The first term here is A1, second term A2, third term A3, fourth term A4, and so on and so forth. How can we find the common ratio? Well, there's a formula for it. You can find any ratio taking any term n and dividing it by the number right before n. And how can you find the number before n? Just by subtracting 1 from that number n. So how can we find the ratio for this geometric sequence right here? It's very simple. We can take any of these terms and divide it by a previous term. I'm going to take a of 4, and I'm going to divide it by what's before a of 4. 4 minus 1. Well, let's still divide 4 minus 1. But I'm following the convention here. N minus 1. A of n, 4. A of n minus 1. 4 minus 1, which is just 3. And I get 40 over 20, which is 2. So my common ratio for this problem is 2. I'm going to keep that in mind as we keep working through this problem. So we can kind of do this easy, right? We're just going up multiplying by 2, right? 5, 10, 20, 40. We can find the fifth term. 40 times 2 is 80, right? But sometimes that's not reasonable. So we're going to have to use a formula. Say someone wanted us to find the large term. What is a of 40? Or a of 20, something like that, right? So instead of doing all this repetitive work, we can follow a formula. And the formula to find any term n is a of n equals a of 1, which is the first term, times the ratio n minus 1. So I'm finding some term n minus 1. All right. So for this problem, let's say I wanted to find a of 8. All right. So if I want to find a of 8, I'm going to take a of 1, which is 5, times my ratio. My ratio here is 2. To the n minus 1. My n here is 8. 8 minus 1, which is 7. So 5 times 2 to the 7. So I'm going to get a of 8 equals 5 times 2 to the 7. Well, what's 2 to the 7? Right. If I have my math correct, I have 2, 4, 8, 16, 32, 64, 128. So that'll be 2 to the 7, 128. Now if I multiply this, let me do some quick math in my head. 5 times 100, 30 should be 650, minus 10 should be 640. So a of 8 is 640. All right. Okay, so that was pretty simple, right? But say we run into a problem. Say we're given 2 terms. and we have to find a ratio, but they're not consecutive. Say I say something like a of 2 equals 9, and a of 4 equals 81. How am I supposed to find the common ratio, right? I can't just do a of 4 over a of 2, and then that'll give me 9. Would that be the ratio? No, they're not consecutive. So I have to do some algebra to find my common ratio. How can I do this? Well, what is a of 2? A of 2 is a of 1 times r to the n minus 1, so 2 minus 1, right? Okay, so, and a of 4 is a of 1 times my ratio r to the n, 4 minus 1. All right, so I'm going to replace 2 minus 1 with 1, and 4 minus 1 is 3. Now I can find the ratio this way, now that I have the tools. So I'm going to do a of 4 over a of 2, which is going to be a of 1, r to the 1 power, r to the, 3 power, over a of 1, r to the 1 power. All right. Now, if I remember my exponent rules properly, right, a of 1 over a of 1 cancels out. This equals r to the 3 minus 1, which is just r squared. All right. Okay, so now I'm going to substitute in the values. R squared equals a of 4 over a of 2, which is 81 over 9, which gives me 9. So r squared is 9. But I'm not looking for r squared. I'm looking for r. So what I'm going to do is square root r squared to find r. I'm going to square root both sides. Square root is cancel this out, so this just becomes r. The square root of 9 is 3. All right. In the context of this problem, it's 3, right? Technically, it's plus minus 3. So I found my ratio here is 3. So for this sequence up here, we have a of 2 is 9, a of 4 is 81. Your ratio here is 3. So that's how you can find the ratio, even if the terms are not consecutive. Well, let's say I wanted to know the sum of a geometric sequence. Well, there's a formula, right? A formula we can use. Let's say I have a sequence 2, 4, 8, 16, and so on and so forth. Right? This is a geometric sequence. First term is 2, and as you can see, it goes up by 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So my common ratio here, is 2. All right, simple enough. Now, the one nice thing about math, we can use formulas. So let's say I wanted to find the sum of the first 6 numbers in this sequence, right? I could add it up, or I could follow the formula, right? So to find the sum of any number, any term n, all I have to do is plug in a of 1, parentheses, 1 minus r to the n over minus r. Alright, so that's how I can find the sum of any geometric sequence. So let's try to find the sum of the first 6 numbers. Right? S of 6 equals A1, here we have 2, 1 minus r to the 6th power. And what's my r? My r is also 2 to the 6th power. See here, 6 terms, 6th power. All I'm doing is replacing the variables over 1 minus my ratio, which is 2. Okay. All right, so let's work this out. So it's going to become 2 times 1 minus, well, 2 to the 6 is 64. 64 over 1 minus 2 is minus 1. All right. So I'm going to get over here, come down here, 2 times negative 63 over negative 1, right? That's going to give me 2 times negative 63 is 126. 126, negative 126 over negative 1. These negatives cancel out, so I just am left with 126. So let's keep that in mind. This is saying the sum of the first 6 is 126. All right, that's what the formula says. Let's see if it actually works out in person. If I take the values themselves, right? So remember, this is saying the sum of the first 6 is 126. Let's look at the first 6 terms of this geometric sequence. And let's add them up manually. 2 plus 4 plus 8, 3 terms of 4, 16, 4 terms, 32, 5 terms, 64, 6 terms. All right, so 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 16 is 30. 30 plus 32 is 62. Plus 64 is 126. So my formula works. I've proved it by counting it manually and also using the formula. All right. Now let's try to tackle a word problem, which can kind of get tricky using sequences. Let's say I have a bacteria culture with 8 initial specimen, which doubles every hour. Bacteria culture with 8 initial specimen, which doubles every hour. All right, so let's break this down. And the problem asks, how many specimen or bacteria after 5 hours? All right, well, let's break this problem down. I have initially, that's my first term, A1 is 8. A1 is 8. All right. And now it's asking how many after 5 hours. Keyword after 5 hours. All right, since it doubles, right? So A2 will be 8 times 2, which is 16. A3 will be 16 times 2, which is 32. Remember, this is how much it starts, right? Start. No time has passed yet. After 1 hour, this is after 1 hour, right? This is after 2 hours. Now, we have to find how much after 5 hours. So, A4 will be after 3 hours. A5 will be after 4 hours. And A6 will be after 5 hours. So as you can see, after 5 hours, I'm not looking for A of 5, right? I'm not looking for the 5th term technically. I'm looking for the 6th term. Let's keep that in mind. Again, I'm going to write here is A1 equals 8. How many terms am I looking for? After 5 hours, I'm looking for A of 6. I'm looking for A of 6. All right. So, let's do this. Let's use our formula, because sometimes the numbers can get really large and it's better to use the formula. What was the formula again? A of n equals A of 1 r to the n minus 1. All right, so I'm looking for A of 6. A of 6 equals A of 1, which is 8. My ratio here, remember it doubles, so it's 2. All right. Over to the n minus 1. I'm looking for 6. 6 minus 1, which is 5. All right. So I'm going to get 8 times 2 to the 5, which is 32, which is 256, right? So after 5 hours, there's 256 bacteria specimen left in the culture. Now, I know, right? N minus 1, you're thinking 5 hours. This should be 5 minus 1. What is 6 minus 1, as we saw, because we counted from the first hour. The key word here is after, right? Now, if the question asks how many specimens are there at 5 hours, we could use N as 5, right? Because since it's after 5 hours, you start at the 6th hour. That's what might cause the confusion between different geometric word problems.